If I have a sine graph, have a look at what I've just drawn. If you want to have a look at it, watch how quick I draw it. You're going to miss it. It's like zoom, gone. That pin's not great. Try this one. Goes up for 90, down for 90, down for 90, up for 90, comes back to there. And what does the graph do? Continues that process on forever that way, continues that process on forever back that way. How long did it take to get to the top? 90 degrees. How long did it take to get to the next one? Another 180, another 90 degrees. How long did it take to get there? Another 90 degrees. It's like it's got 4 sections. And later on we're going to talk about those 4 sections. And that would be 0 to 90. And that would be 90 to 180. This is what's coming a little bit further up. Did we do this last year at all? And that would be 180 to 270. And that would be 270 to 360. And you could keep going around the loop. Yeah? How long does it take for this graph to repeat its pattern? How many degrees for it to repeat its pattern? How many degrees to go all the way around there and get back to there? 360. How many degrees to go from there all the way across to there because it's ready to repeat? 360. Okay, we talked about that for the period. I like using P for period. Some people use different things. So the period for sine is 360 degrees. You okay with that? It takes 360 degrees to repeat itself. We could talk in radians, but I don't want to talk in radians at the moment. Just get the hang of it in degrees. So what would happen in the light of what we did yesterday in transformations if I turned it into a sine of 2x? If you multiply by 2 on the inside, outsides are, thank you, outsides are vertical. So I really only gave you that one rule. Outsides are vertical, maybe that's what I'll do from now on. So insides are horizontal. Outsides do what you expect them to do, it's an inside. So it doesn't spread it out by twice as far. What's it do? Halves it. Now if you weren't sure of that, I could draw up a table afterwards in a slow explanation. Draw up the table. But if you're at the point that your brain can go, insides do the opposite of what we expect. So instead of having now a period of 360, we're going to halve it. So how long will it take for the graph to repeat itself? 180 degrees. Now what's what I do on my graph? Basically, this is where I talk about my graph's going to look a bit munted, a bit funny. I know I'm going to do one of those, I know I'm going to do one of those. Normally that would have been 360. So if I went to this graph, it's y equals sine x. And it took 360 degrees to repeat. If I go to this graph, it's also sine x, but it's not sine x, it's now going to be called sine of 2x. Did I draw it identical? Yes. How long did it take to repeat? 180. So if you want to draw up a set of tables and put the numbers in, by the time you get to 180, you've gone through the cycle of what's going on. So what would happen if I had y equals sine of 3x? The period would normally be 360. And what am I going to divide it by? 3. Now if you want a rule, so the understanding is it's multiplied by 3 on the insides, opposites do what we expect and they're vertical, insides do the opposite of what we expect, so it's not a times by 3, it's a divide by 3, and it's not vertical, it is horizontal. Really, when I was at school, did I think that? My teacher wrote on the board the periods 360 on n. And he said the n comes from there. So my brain would just go 360 on 3, so it takes 120 degrees to repeat itself. So I could draw the next graph and draw the same thing again, goes up to here, across to there and over there. And instead of calling that now 360, what do I call it? 120. Now be careful on the numbers. If that's 180, what's this one here? 90. So by the way, what did the 2 do to the graph? Squashed it up. I probably should stop and redraw the graph to that scale to get your brain seeing what really is actually going on. So let's do it again. I'm going to go like that there. I'm going to go there's 360. How long is it going to take to repeat itself? 180. So instead of going like that and like that to there, now it's going to go, I've got to get it repeated by there, so squash it up to there, down to there, down to there, up to there. So this one will go up to there, oops, down to there, down to there and up to there. And by the way, it goes up to 1 and down to 1. Up to 1 and down to 1. So you can see my graph's gotten a bit munted. Yeah. So if I drew this one to the same scale, what happens to it? By the way, how many times does it repeat? This one repeats twice in 360. This one will repeat 3 times. There's so much understanding you can get out, but most of the time you don't need that understanding. So I'm going to have trouble drawing it. I'm going to say that was 360, that's 360. So I've got to repeat it 3 times. So I've got to go one of those, another one of those, another one of those. Yeah? How long did it take to repeat itself? 120. Can you imagine putting the numbers on? There's 360, there's half of it, half of that's 90. And we count, oops, and then you're counting all the numbers, and you can start figuring out what they are, that's a 270. And you can go on and on and on with the sine. Now, that's the basics on a sine graph. What if I try to muck you up, what do? This is getting too long, but I think I need to take my time on it. What if I had the sine of a third of x? This go rule, you want to go understanding? You could say multiply by 3, or you can go the period is 360 on n, which is 360 on the third. And people get mixed up with their fractions. Widens out by a factor of 3, becomes 3 times wider. What happens when you divide by 3? Invert and multiply, turn that, so there's your invert and multiply. It's like saying how many 1/3 would go into 360? How many 1/3 go into 1?
3.
In 2?
6.
Into 3?
No.
So you're just multiplying by 3, which is invert and multiply. So that'll be 900, that'll be 1,080 degrees. So if I drew this to that scale, I'm going to go, there's 360, there's next one, there's 1,080, and I'm going to have to repeat by there. So I've got to go up and down to there, down and up back to there. Oh my goodness, it's annoying. How far up did it go? 1 there, -1. First detail. All of cos does the same. So you can go to your cos graph and say what would happen to the cos graph. You're right. That's one of the details. That's about the period. Now we talk about the amplitude.